again. It's time to go through these next three tools. We're going to start with hollow, go on to the make pattern, and then end with separate shells. The hollow and the separate shells goes pretty quick. There's not a lot to look at, and so we'll spend most of our time just exploring what different things are in the make pattern, even though in dentistry there's not a lot of indications for using it. In the hollow, when you select hollow, what it says is that the make hollow is utilizing a lot of what we saw in make solid. If you remember in make solid, if you switch it to accuracy mode and you change the offset, we use that to make an object bigger, to bully it into another, to create that space. Well, what the hollow is doing is the opposite. It's doing the same thing, but it's bringing the shape onto the inside of the object. Okay, so and it shows you this nice preview. I left the wireframes on because I want to show you what's going on. I wish you could not see the wireframes on the outside and only see them on the inside, so you'll have to look carefully with me. But if you look past, you notice on the outside these triangles are rather large. So if you see small triangles, it's the inside, not the outside. So if you look at that, that's going to create a mesh on the inside with a higher resolution. Now, if you're just trying to print a hollow model, you don't need high resolution on the inside, and you can change that. Okay. Also, depending on the shapes on the inside that are created, you can change how well it adapts using these things, same as you did when you were doing the make solid and you want to improve the look of it. You could drag those up, but it's going to cause the resolution to go up. And so what instead I want to show you is if you bring the mesh density down and you hit update model, notice what it does to the triangles on the inside of the model. So if I zoom in, see how those triangles just got to be bigger? And if I bring it in again, update, and again, notice, look closely on the inside, see how the triangles on the inside are getting rather large. Okay, that's just one thing that you have the power to mess around with. Okay, what I want to show you next is the tool that they have for creating holes. Why would you want to create a hole? The idea with that is, the reason we use this tool the most in dentistry is to hollow out a model, but then we plane cut the bottom off. Okay, but if you actually want to print something hollow, what you run the risk of is trapping inside your model uncured resin, or if you're doing like laser sintering, some powder gets caught on the inside. So creating holes is a useful tool. I know that one indication that we use this for in our practice is actually to create a hollow frame for 3D printing. So for our hybrids, what we're doing a lot nowadays, because we don't have a mill that can mill metal, we're outsourcing the milling of the metal, but we're doing it through 3D printing. And the problem, so when we first tried it, it was very heavy, and that was a problem. It came back and it was a very, very heavy bar, and we wanted to lighten it up. So we worked with Bertram Dental Labs, and they're the ones who actually came to us saying, hey, if we hollow it out, it gets lighter. But then we started hollowing them ourselves. So we would design it in ExoCAD, and then after it was designed, we'd bring it into Mesh Mixer to do the hollowing. And when you hollow the model, it needs to have holes so that that powder can get out. And so we would use the tools here to be able to do that. So right here where it says holes per hollow, that you can drag how many you want. Okay, so if we put it at 3, and we can say how big we want it. Here, let me do this, generate the holes. So notice that these holes, for some reason it's only showing 2. It's probably because of how few triangles there are down here, because it will fail and not be able to do holes if you don't have enough mesh. I bet if I remeshed that, it would allow for the 3. But notice here I can change my hole diameter, okay, and then also I can change the hole taper. I have it taper this way or that way. Okay, you can kind of see what's going on right there with that taper. Also, you can drag these around, reposition them into a different place. Okay, so see right there. And then the other thing I wanted to point out is that if you double click on one in the red spot, it makes it go away. Okay, so that's just a quick way to delete it. And then let's go ahead and hit accept. Let's see if I covered everything. So that offset distance is how thick the model is. So if we wanted it to be thicker, you could change that to 3, hit update model, update hollow, I mean. And now you can see there's a thicker one, and this time we'll just do 1, generate hole, and we will go ahead and just leave it big with the taper. Let's see, let's taper it this way. All right, so if that's the way we want it to be, we can hit accept, and it's gonna go ahead and make that for us. So you can see what it's made for us is it put this hole right through the bottom, and you can see up inside there that it is indeed hollow. Okay, if you wanted to see that further, plane cut would be a wonderful way to look inside your model to see what's going on. So you can see right down through there, and if I were to cut through the hole, you can see that there's the hole right there. Here, I'll just hit accept. So you can see right there that the hole is there, the model's hollow, and it has a thickness of 3 millimeters. Okay, so that's the Make Hollow tool. I'm gonna just delete this and go to this guy here, because this is the bunny I brought in for the Make pattern. Okay, the reason I brought this bunny in specifically is I have already gone and hit select all and did the reduce to change the size of those triangles to be much larger. And the reason I wanted to do that is I want to show you what the edges tool does. So if you notice right here, I'm gonna shrink these dimensions. What it's doing is it's putting a cylinder right along every triangle. So these triangles right here, and I pre-made some of these so I can show you what I'm talking about, but it puts it right along the triangle. This one right here that says dual edges, it does a slightly different thing, and it'll make a lot more sense when I show it to you over here in comparison. But what that does is it essentially, if you have an edge right here, it goes to the center of the edge and it makes that now like its own edge, I guess you could say, and I'll explain that further later. I still don't understand these next two. I'll show you what I ran on them and how they look slightly different. I'm not too worried about them because I don't see myself ever using them. I think maybe they're more for, you know, artistic expression. The tiled tubes, if you look at these, notice that it's running these tubes all the way through your model, and you can change the size of those tubes. See how I can change the diameter of them, but also there's this 7.5 millimeter space between them. If I brought that down, you're going to notice there's going to be a lot more tubes. Okay, and then once it has created these tubes running through your model, then you can choose if you want to subtract. If you do subtract, it keeps all the parts of your bunny minus where the tubes are. So it's going to look like there's holes going through your rabbit. And I'll show you an example in a little bit. If you change it to intersect, the difference there is that now it keeps the part inside your tubes that the rabbit touched. Okay, and I'll show you what I mean by that. But it'll look like a bunch of tubes all stacked together in the general shape of a rabbit. And obviously if you decrease the spacing between them, the end result's going to look a lot more like what your original object started as. When I show you the example when I didn't do that, mine was left more like the one that we had before. You'll notice that, yeah, I mean, it's kind of the shape of a rabbit, but if you didn't know it came from a rabbit, it wouldn't look like a rabbit. Clip to surface is talking about some of these tools will do stuff to, like for example, when we were looking at the edges one, okay, notice that my original bunny is the see-through one, and it's creating these cylinders that are making it larger, which would make my bunny larger. Well, if I check the box to clip to surface, I don't think it shows it in the preview, but after you run the tool, it brings everything in so that it's not sitting out, so it doesn't make it bigger. Okay, it kind of pushes everything in so that it's flush with the surface of your original. And then these ones are all about just changing the sizes of the triangles. I have no idea what gradient is. The documentation doesn't really touch on it. I didn't really play around with it because, to be honest, I don't use this tool very much at all. Let's go back up to the pattern types. So that's the tubes, spheres. So if you go to the spheres, you can see that there is it's not random. You can see where the grids lie, okay? The other thing I want to mention is that there's a tiling mode. There's two options. This is a hex grid. Think of a hex grid as like a hexagon, and how hexagons might fit together if you put them all together. So like they're kind of like offset just a little bit. If you change this to regular grid, you'll notice that, you can see this a little better right there. So notice with regular grid, we are seeing more like spheres set like row by row, where the columns and the rows all line up. Whereas if I take this and see how like there's spaces in between these, but if I switch it back to the hex grid, like one row is going to still be the same, but then the next row behind it, I'll move it just like that. So see how one will line up pretty good, and then the next one is kind of off just a little bit and nestled up in there. So that's the difference there. But anyway, the tiled spheres, if we decrease the size, you'll see it a little bit better. But you can see that it is creating this grid, and that grid can be seen in a few different directions. Okay, a lattice creates kind of this 3D lattice of cylinders. You can see that, right? So if you put it on this angle where you can see right straight through the lattice, or if you turn it over this way, you can see right straight through the lattice, or this way, same thing. And it's the same thing. You can create this shape running through your object, or you can keep those tubes but have the outside cut out so that it's in the general shape of a rabbit. Let's see, random primitives, and by primitives it means spheres, but random primitives in the volume space basically just sticks a whole bunch of spheres throughout the rabbit, so they're not on a grid anymore, they're just kind of randomly in there. And if I change the dimension of those spheres, it begins to be a little bit easier to see. I'll bring it down just a little bit more. So you can see these are random spheres all throughout our object. I mean, depending on what you're doing, you might need that. But then if you put surface, it does the same thing, random spheres, but now it's attaching them to the surface. And with this one, if I make them very small and I put my spacing small, you'll see it creates a lot of them, but notice how they're only on the surface and they're not down in the middle, okay? If I were to select the clip to surface, it would move them all inward so that the final product isn't larger than the beginning. And then this last one is an interesting one, which I need to use on a different model because it uses face groups. I'm going to hit cancel, and I'm going to hide this guy, and we're going to go down to the bunny with the face groups. And so see how I've created these face groups using the plane cut tool? Okay. If I go into the Make Pattern tool and I choose the face group borders, notice what it's doing is it's taking cylinders and it's running those cylinders right along my border. And if I change the thickness, I can make a larger tube that goes all the way around. And you can see that there's some spaces here in between those cylinders. Those get filled in, okay? You hit accept, it will make these tubes that run along those borders, which is, it's kind of interesting. I mean, you could make a bracelet that way, I guess, custom bracelet, scan your wrist and add a face group. But so that's just another tool. I'm going to show you now some of these tools. I'm going to hit cancel. So this right here is what I got when I ran that specific tool. I'm going to turn off the wireframes now. And so what it did is it made this tube that goes all the way around. Let me turn this off. So you can see it went all the way around and created this tube right where that face group was. Okay, so that gives you some thoughts on what you might do that with. To be honest, this is the one part that I found most interesting and kind of made me think, I wonder when I could use something like that. But that's that one. Then let me turn this guy back on and this off and go to here. So now I want to turn back on the wireframes because I want to show you a couple of these things. Remember when we talked about edges, which was the first one in the drop down, notice how it made a tube along every edge. I'm looking at my rabbit being like, hey, where'd my tubes go? Or sorry, where'd my edges go of my triangles? Well, you just don't see them because everything's covered up. I'm going to toggle this on and off. And so you can see, like, look right here. And I'll toggle this on and off and see how it covers everything exactly. So then the interesting thing is when you say dual edges, it does a different thing. Okay, it's a different pattern. It's actually, and I'm going to toggle it on and off. Again, so I'm going to choose one spot, stare at it while I toggle it on and off. And you can see what's going on. It's putting the tube perpendicular to every one of these edges. Okay, so now our tubes are running outward. Like if you choose one triangle right here, let's do this. I'm going to select one triangle, just like that. Okay, so if you look at one triangle, every single one of these are the same way. Every triangle has it going through like three directions. Okay, and so then if you got them both, you can see now you're really ending up with a fancy looking object. All right, so then I want to show you that these other ones, they do the same thing in that they covered all this, but look at all this extra stuff. Okay, it almost looks like we've got our normal stuff, but then at where everything comes together, we have extra things. It almost looks like they're starting, but they don't finish. So maybe if you played around with the settings, you could get more of those to go out and connect, like right through here. I think we have a lot more of them connecting. Like if we toggle this on and off, see that right in here where it's a little dense, it's getting thin on this one right here. Okay, but right through here, everything is connecting. And so that seems to be, and then this one does the same thing where you still have all of these touching, but then you can see there's extra pieces hanging off. So like I said, I don't fully understand those, but just wanted to show you at least that much. So then when you do those tubes, where we saw those tubes, like that grid of tubes running through, this one right here is what you get. Let me turn this off. This is what you get if you keep, this is the subtract option, okay? This allows you to keep your bunny, but subtract the tubes from it, okay? So you get this interesting look. I guess technically you could plane cut this right here, lay it on its side like this, and now you have a little instrument holder for your lab. But that gives you an idea on what that tool does. If I turn that one off, now this it's hard to tell that that's a bunny, but like here's his nose, here's one of the ears. But this is what it looks like when you do the intersect option. If you combine these two together, you can start to see what each of them are doing. The subtract keeps the bunny but cuts through where the cylinders are, and intersect does the opposite. It keeps the cylinders but it uses the bunny to cut them down. And if you can see, there's a lot of the ones that just aren't lined up. If you messed around with the settings enough, you could get a much better relationship between the two. So that's that tool. Okay, so let's go back to our bunny. I'm going to turn these ones off, and I want to show you that if I'm going to duplicate my bunny and move him just a little bit off to the side. Maybe we'll shrink him down and stick him there, and then accept, and then let's duplicate again. I just want to have multiple objects here. Okay, So we've got these bunnies right here, and the tool that I want to talk about is this one called separate shells. Separate shells is the opposite of the tool that we call combine. So you have combine and you have separate. Combine, separate. And if we select all these and hit combine, which I learned, I didn't know this, but I learned that once you select objects, if you hit Y, it's a shortcut for combine. You learn something new every day. Learned that while I was doing my research. So I love that because I combine and separate things all the time. So that combines them. Now, one thing I want to note is that when something is combined, it just sticks them together. Notice that you can still see that these are all separate STL files. If I were to go and click on one of them and click E on my keyboard for expand to connected, you'll notice that it still is only connected here. They're not like part of each other. If I were to Boolean this bunny into this one, like a Boolean union, it would eliminate any areas where they overlap, but it would still look similar to what you're seeing. So anyway, the tool that we're covering is the separate shells. So anytime you have an object that's made up of multiple STL files that are all kind of stuck together, if you run the separate shells tool, it separates them into different pieces. So for example, if you were looking at, we'll look at this one down here at the bottom. If you brought in, I'm just going to keep it simple and bring in one arch instead of a full arch, but if you brought in the Christian Brenna's teeth and you position them where you wanted them in the mouth, like let's say you had a model of teeth in here and you're taking these and you're moving them as a whole to get them to align, and then you want to start working with them individually. I mean, I do it differently than this. I'm just kind of thinking of what is in an instance that you could use this tool, and it might be taking a while because of all this stuff that I have in here. I probably should have removed that first. But you could use this tool to take all these, because all these teeth is a bunch of teeth that are all different STL files that have been combined together. So this will simply just separate them all out. Okay, so here we go. I'm going to turn off the wireframes because these are high resolution. All right, so let's say you've got these and you had them in the mouth and you moved them around and you got them where you want them to be. They're right there is perfect, but you want to move a couple teeth on their own. What you can do is use this tool to separate these out into individual STL files. Give it some time. Again, I think I have too much stuff open, especially when I ran all these edges and dual edges and mesh tool. That created a lot of triangles. In fact, maybe after this is done accepting, I may delete a lot of that stuff, because normally moving these teeth around doesn't take this long, but I think it'll be there pretty soon. Okay, so before we move on, let's just select all of this. We don't need any of this anymore. So we're going to delete all of that just to help us out. All right. So then, now that we have our teeth set here, we can come over into edit and say separate shells, and it's going to separate each of these into their own STL files. It really doesn't change anything with what the object is. It just breaks it out into separate pieces so that instead of 12 STLs that are all combined, you'll notice in the object browser right now that it shows that there's only one STL file, even though it's made up of 12 different ones. After running this tool, it's going to now show that there's 12 different STL files. All right, so if you look right here, now we've got shells all the way down through here, okay? And I said 12, I didn't actually count. I assumed 12, but I forgot that there's a second molar in here, so it actually is 14. So you can see that all the way down to the bottom. You've got all those shells. And technically, if you selected all these shells, you could reverse what was just done by just clicking right here where it says combine. So hopefully today's, the tools that we covered today help you to better understand some of the things that you can do to not just be more efficient with what you're using these for in dentistry, but also to play around a little bit.